All right, everyone. So today we're going to go to the chapter 19. We're going to start with two dependent sample t-test. So we're still going to talk about the inferences. Everything we have here is about the inference. Okay. We just have two more tests to go. One is to dependent sample, and the other will be to independent sample. And we're just going to focus on the t-test. We can do confidence intervals as well for two samples, but it's not as common as the hypothesis test. So the learning objective, we need to understand how to determine if two samples are being dependent or independent. Okay? So when you compare two group samples, if the two group samples are dependent or independent, we need to treat them in different ways, have different procedures to treat them. But how do we determine if they're dependent or independent? Okay, so we're going to talk about that. And in this chapter, first we're going to talk about if you have dependent sample. Then we need to use a procedure called the pair t-test. Okay, you have independent samples. Then we're going to use a different procedure. We're going to talk about it next video. And in the hypothesis test, we're going to focus on the 5-step procedure, right? So don't forget about the 5-step procedure. Make sure you understand each of the steps. Right. So first, we're going to talk about dependent and independent. Okay. This is just about the design of the study. For the same purpose of the research, if you design your study in different ways, then you need you could have different scenarios and need to treat the scenarios differently. So for example, here, we want to evaluate a workshop to see if the workshop is, effective. Is it really serving the purpose? So a lot of times, when the first-time freshmen, when they come to college, some people are behind in the math skills. So, then the college will provide some workshop to help them to catch up with the math skills. So in this case, there is a workshop, then how effective is the workshop? Is the workshop really serving the purpose? Someone need to evaluate that, right? Then how do we evaluate that? So here's the idea. In the first scenario, we want to see if the workshop is helping. So then in the design, we have 10 students randomly selected with similar math background, and they are each given a pre-test before they attend the workshop, and also a post-test after they attend the workshop. So basically a test of the same difficulty level, but these different tests are given before and after, the students attend the workshop. Then we have two groups. One group is before the workshop, the other is after the workshop. We have two group samples, right? Then the question is, are the two group samples dependent or independent? And here, the dependent and independent is the same meaning as when we say two events are being dependent or independent in the probability rules. Independent just means one doesn't affect the other, right? Dependent means one will depend on the other, will affect the other, right? Okay? So when you think about the scenario here, are the two group of scores dependent on each other or not? So if a student is very, very good, for example, he got 89 on the pre-test, what do you expect his post-test score to be? He knows very well on the math concepts. Then after the exam, he should get a higher score as well, right? So the score, this score and this score will be related, right? The same reason, if someone is struggling in a pre-test, what do you think the post-test will be compared to the good student? He will struggle as well, right? So the two scores are affecting each other. They are related. They're being measured from the same student at different times, right? So the student ability will have relationship to both scores. So in this case, we have dependent sample. Right? The two groups of samples depend on each other. If you do that, all good students, you get high score in the before test, the post test will be 10 to high, right? They're related. All right. Then for the same purpose, we still want to see if the workshop is effective. Basically, the same idea. But now we're going to design the experiment in different ways. So in this case, we randomly choose 10 students with similar math background. And now we're going to divide the 10 students into two groups. And one group will serve as a control group, and the other group will go through the workshop. So we're going to have a group of the students go through the workshop. We have a group of students who doesn't go through the workshop. Then we have a group workshop goes through it, a group control who don't go through workshop. So the score measured from totally different students, right? So in this case, are the two group samples dependent or independent? So basically, will the score on top affect the score on the bottom? In this case, there's no relationship, right? They're measured from totally different students, right? No matter how high the student score on the when they go to workshop, it's not going to affect the student score on the control group because they're totally different students, right? So in this case, we have independent samples. Okay. So we work with two sample problem. If you have dependent sample or independent samples, we need to work with a different process. Okay. So for dependent sample, we need to go through an inference procedure called a paired t-test. And that's what we're going to talk about today. And if you have two group samples being independent, we need to use a different procedure. That will be called a two independent sample t-test. And most of the time, we just call it a two sample t-test. So when you say two sample t-test procedure, that's referring to two independent samples. Two dependent sample procedure, we call that a paired t-test. Okay. So this is the first animal of this video. This is the raccoon. This is for attendance points. Make sure you answer the questions correctly for the attendance. All right. So then the common dependent sample scenarios will be the two samples are measured from they're measured from the same group individuals. Like the earlier example we have, measured before and after, but from the same group of people, before and after. Okay. Or in the same samples are being measured at different times, so they're related. That's one scenario. And the other scenario is they could be different individuals, but those individuals need to have a relationship. They need to be sampled in pairs. So if the two group samples are sampled in pairs and they compare between them, you need to use pair t-test as well. They are considered as dependent. So for example, if you want to compare your strong hand and your weak hand strengths, they're coming from the same person, right? So they'll be dependent. If you're comparing the husband and the wife satisfaction level within a marriage, how happy they are in the marriage, but you're comparing the husband and wife from the same marriage, same couple, then that will be dependent as well, right? Basically, if one party is happy, the other party tend to be happy as well, right? So they're dependent. Or twin brother and twin sister, you're comparing their IQ scores or height or anything related to them. They're coming from the same twin family, then they're dependent as well, right? So two scenarios. One, the two samples are measured from the same group individuals. Two, the two samples are selected in pairs. Okay. Then we need to do a pair t-test for the two dependent sample. But how do I do pair t-test? If you understood one sample t-test, then this is very similar. We just need to do one additional step. So we need to find the paired difference first. Okay? So basically we have two groups, right? Before and after, we're going to define a difference. But you're going to use either after subtract before or before subtract after. It doesn't matter. You're going to calculate the difference either way, right? And then once the difference is calculated, we're only going to focus on difference and perform a one sample t-test on the difference that's being calculated. Okay. So the only difference between the pair t-test and the one sample t-test is we need to define a new variable. And that new variable is the difference between the two groups. And everything else is exactly the same as a regular one sample t-test. Okay. So now let's look at an example. Maybe, it will help us to get this straightened out. So for example, we're saying an electric company has provided their consumers a booklet since over a year ago to show how to save electricity. And we want to see if the booklet is effective. We want to see if it really does help, right? If it's helpful, then the electric company can keep sending the booklet to people, to the residents. And if it's not helping, then it's kind of wasting money to send it, right? Okay. So in order to evaluate the booklet's effectiveness, they collected a simple random sample of 10 consumers. So basically they selected 10 residents and they recorded the electricity use for the whole year before and after they sent out a booklet. So they measured out, their electric use before they sent out a booklet for the whole year and after they sent out a booklet for the whole year. And they want to see if there is a change, right? So you're asked to see if the booklet is effective based on the data provided to us. So can we tell if the booklet is effective from the data being collected? Okay. All right. So in here, basically, we have two group of samples, right? We have before group and we have after group. Are the two groups dependent or independent? Of course, we're talking pair t-test. They need to be dependent, but you need to understand why, right? So think about the two groups of measures. They are measured from the same household, right? If the household before, they use a lot electricity, after they're going to use a lot of electricity as well, right? Depending on how big the house is, right? How many people are in there, right? So they are dependent, right? It's measured from the same house, before and after. So the value will be affecting each other, right? Okay. So since they're dependent, that means we need to do a paired test. Okay. So then, how do I do pair t-test? We need to first define a difference, a paired difference, right? Before and after. And then will be just a one sample t on the difference. Then how do we define difference? You can define the difference either way. Basically, you're going to have a difference being defined. And the difference can be before, subtract, after. Or you can use after, subtract, before. Either way. So what you do is, for example, if you use after, subtract, before, then you're going to use after electricity, subtract before electricity for each of the household. Okay. So for example, you're gonna get a difference, and this difference is after subtract before when you look at the values. So then you can have 10 different values for difference now, right? Once the difference is defined, you're only gonna look at the difference here. You're gonna ignore the before and after. They're not important anymore. Okay? So we're gonna do a one sample t-test on difference. So that means you need to remember how to do the one sample t-test from chapter 18 we just talked about. Okay. So let's work on this. Like I said, because we have two samples being dependent, we need to go through a process of a parity test procedure. Right? So when you do parity test, you need to define a difference first. And in this case, we define a difference as one group subtract the other. We use before after group subtract the before group. Then afterward, it will be a one sample t-test on the difference. And for any hypothesis test, we need to go through the 5-step hypothesis test process. First step, stating hypothesis. So then, in this case, what is our hypothesis? We're trying to compare the two groups, after and before. And the alternative hypothesis will be the booklet is effective. So effective means the booklet is going to help to save electricity. Right? So that means after the booklet is sent, we need to use less amount of electricity than before. Right? So the booklet is effective just means this, they're equivalent. Right? Then we need to convert this claim into something related to difference because we need to do a test on the difference. That's how we do a parity test, right? Okay. So now let's convert this into difference. We can basically subtract before on each side, and then this will be equivalent to this, right? Just kind of rewriting it. And then we realize this will be the define the difference. Right? So the booklet is effective is indicating the difference we define need to be a negative number. Right? That means we're saving electricity afterwards. So then the mu of the difference need to be less than 0. That's our alternative hypothesis. And then the null hypothesis simply change the sign to equal sign. So I use D to represent the difference. Mu of the difference is equal to 0, and mu of the difference is less than 0 as our null and alternative hypothesis. Right? So the first step is done, stating hypothesis. Then second step, state rejection rule. So rejection rule is always the same sentence, regardless what kind of hypothesis test you're doing. If p-value is less than alpha, then reject the null. So then the question is, what is alpha, right? Are we given alpha value here in the problem? We're not given alpha. Oh, we are 0.05, right? Okay. So then we need to use 0.05 here as alpha. So step 2 is done. Okay. Then we go to step 3, calculating test statistic and find p-value. So pair t-test, in a sense, is a one sample t-test. It's one sample t-test on the difference, right? Then we just need to borrow the formula on the one sample t. So the calculated t for one sample problem will be x bar minus mu divided by s over square root of n. Then in this case, keep in mind everything in here is referring to the difference, right? So x bar of the difference, mu of the difference, standard deviation of the difference, and the sample size of the difference, right? Now let's find what each of the values will be. What is x bar of the difference? What is mu of the difference? What is s of the difference? And what is n, sample size of the difference? So now you go back here and you take a look. After you calculate the difference the variable you're focusing on, disregard the original two variables. Then for this variable, you can calculate the mean, you can calculate standard deviation, and this is mean of the difference, this is standard deviation of the difference, right? And what is sample size of difference? Basically, how many different numbers we have, right? We have 10 households. For each household, we can calculate the difference. Then we have 10 different differences, right? So sample size of the difference goes to 10. Then, we bring these numbers in. 534.5, that's x bar. N of the difference is to 10, and the standard deviation of the difference is 967.8. And then what is mu of the difference? We need to always assume the null hypothesis is true, right? If you assume the null hypothesis is true, mu of the difference is equal to 0. Okay. So then we can calculate this. We bring all the numbers in. X bar of the difference, 534.5. Subtract mu of the difference equal to 0. S of the difference, 967.8 divided by square root of n and equal to 10, right? And we can do the calculations, right? If we calculate it correctly, I think we got 0.53, 1.74. Okay. So then we calculated the test statistic. Now we define the p-value. Just like in a one sample t-test, the p-value will depend on your alternative hypothesis. Right? Alternative hypothesis is smaller than sign. The p-value will be probability of t smaller than calculated t. And the calculated t is 1.74, replaced it in there, probability of t smaller than 1.74. Then this is a t event. I want to evaluate this on the t table, but the t table only allows greater than sign. I need to convert it. So there'll be probability of t greater than, and then we need to change the number sign when you convert it, negative 1.74, right? And this is something we talked about as well. Probability of t greater than a negative number is always higher than half of the whole distribution, right? For any t distribution, it's symmetric, bell-shaped, center at 0, right? Greater than negative number will be more than a half, right? So there's no reason to go to t table this way. It's always going to be higher than 0.5. Right? So then we find our p-value. It's pretty big, right? Then we go to 4. So now we know what the p-value is. It's greater than 0.5, and alpha is 0.05. Then we can make a decision. P is definitely greater than alpha, right? 0.5 is greater than 0.05. Then you go back to the rule. If P is less than 0.05, we reject the null. But now P is greater than 0.05, so we're not able to reject the null, right? So we're going to say we fail to reject the null. And the last step is conclusion. So we write our conclusion. Since we failed to reject the null, we say we don't have enough evidence that. After that, you bring your alternative hypothesis in here, right? Alternative 2, that the booklet is effective. And this is based on significance level of 0.05. Right? So that means we basically our conclusion means the booklet is not effective. We can't say it's effective, right? So it's not effective. Then if the electric company sees this, it's going to say, hey, you know what? The booklet's not helping. Maybe we're going to, not do it. Waste money. But keep in mind, even though it's concluded the booklet is not effective, but we could make an error, right? Our conclusion is not always 100% correct. There's a chance we could commit an error, right? So what kind of error could we commit here? Type 1 error or type 2 error? Right? So don't forget, when you fail to reject the null hypothesis, we're going to have a chance for type 2 error. Right? So that means even though we concluded that the booklet is not effective, but it might actually help, right? It might be like effective, as a reality, right? So if you're the manager, you believe, hey, you know what? Even though you tell me it's not effective, but I think maybe you have an error in your study. So I'm still going to send out a booklet. But, it's up to whoever the manager is to make a decision. We're trying to help to make a good decision. But, they can still make whatever decision they want to make, right? So this is an example of, a PRT test. Now let's look at another example. A dual energy X-ray absorptiometry, DXA. This is a technique for measuring the bone health. One of the most common measures is total body bone mineral content. A highly skilled operator is required to take the measurements. And recently, a new DXA machine was purchased by a research lab, and 2 operators were trained to take the measurements. The lab wants to make sure that 2 operators will be able to produce the same results. So that, they were asked to measure 8 samples, and here are the data. So in this case, we have 8 samples, and they are measured by 2 operators. Operator 1, operator 2, right? This is sample 1, sample 2, sample 3, and you have 8 samples in the end. It's the same sample, just being measured by different people, right? So from the data, we need to see if the 2 operators are producing same or different results, basically. So what does the lab want to see? They want to see the 2 operators are producing the same results, right? Because if for the same sample they're producing different results, that means at least one of the operators is not trained correctly, right? Then they're going to have issues. Or maybe both are trained not correctly, right? So then from here, can we help to analyze the data to tell if the 2 operators are trained the same way or in different ways? Okay. All right. So obviously we have two group samples, right? Two groups, we're comparing them. Are the two groups dependent or independent? Right? So think about this. You have the same sample being measured. If that sample is rich in bone mineral content, the both number should be higher, right? If that sample is, low in bone mineral content, then both measure will be smaller, right? So those two samples are dependent. They're basically same individual being measured at different time or by different people, but they're same sample, right? So they are dependent. Okay. And then if you're dependent, then the process we need to use for two dependent sample, we need to do a paired t-test, right? So for paired t-test, we need to define a difference. You can use any group, subtract the other group, doesn't matter which one first. You can use operator 1, subtract operator 2, right? And once the difference is defined, you can calculate the corresponding differences, right? So corresponding differences, the first subtract second, you're going to have a data for just the difference, right? Once the difference is calculated, only do a one sample t-test on the difference, you can ignore the original data, right? So that's the process. Okay. And the first step of the hypothesis test procedure will be always write your hypothesis, right? So what is a hypothesis here? So we know this is a pair t-test because they're dependent. The first step, well, we need to define the difference here as operator 1 subtract operator 2, and then we're gonna go through the 5-step process, right? So first step is stating hypothesis. You have null hypothesis, you have alternative hypothesis. So the alternative hypothesis is basically the two operators will give you different results. Right? And the null hypothesis will be the two operator will produce the same result. Then what does a claim mean? It means operator 1 measured value will be different from operator 2, right? But we need to write this in terms of the difference we defined because their test will be on the difference, right? So then we rewrite this, will be operator 1 minus operator 2 will be different from 0, okay? And then this is our defined difference. So we want to see if difference is different from 0. And that's our alternative hypothesis. So mu of the difference is not equal to 0 versus the null hypothesis is mu of the difference is equal to 0, right? And step 2, if p is less than alpha, then reject the null. It's the same sentence all the time. We just need to determine what alpha value to use. And then here we're given alpha equal to 0.05. Even if you're not given 0.05, the default is 0.05 as well, right? And step 3, we need to calculate test statistic, just like a one sample t process. P T will be x bar minus mu divided by s over square root of n, and then we calculate, right? So everything here will be with regard to the difference, right? So then we go back here. So if we define the difference as operator 1 subtract operator 2, so corresponding difference, we can calculate 8 different numbers for the variable difference, right? Once that's calculated, operator 1 and operator 2, they're gone. We don't need to worry about it anymore. We're only going to focus on the difference, right? And for this difference, we can find the mean, we can find the standard deviation, just like how we learned to do it in chapter 2, right? So by the end, we can see that somehow mean x bar will be negative 0.0015, and the sample standard deviation, I mean they're both about the difference, will equal to 0.0122, right? Again, if you struggle with this, finding mean and standard deviation, refer back to the questions you learned, you practice in chapter 2. So the mean is negative 0.0015, standard deviation is 0.0122. Mean of the difference is negative 0.0015, and then mu of the difference will equal to, right, from the null hypothesis equal to 0, and then n of the difference will be 8, right? You have 8 different samples being measured. So you plug in that into the calculation, then x bar mu s and n, and we calculate it. Right? So through calculations, I'm gonna skip that. It's negative 0.348. Now we can look this probability up on the t table, right? So the p-value will depend on your alternative hypothesis. Your alternative hypothesis has not equal sign. P-value will be 2 times probability of t greater than calculated t's absolute value, right? That's something we practiced before. For different alternative hypothesis sign, your p-value will be in different forms. Don't be confused. And then the calculated t is right here. We're going to replace it. It will be 2 times probability of t greater than negative 0.348. Take the absolute value. Then get rid of the absolute value function. Will be positive 0.348. And we can look this probability up in the t table with degree of freedom equal to -1, right? N is 8, -1 equals 7. Then we're going to check on the t table. So with degree of freedom equal to 7, our t-score only have one neighbor, and that neighbor is 0.711, right? With the corresponding probability is 0.25. Then our probability of interest will be higher than the probability of that, 0.25, right? But our p-value will be twice as big. Don't forget a factor of 2. So our p-value, you multiply 2 by both sides, right? So our p-value will be greater than 0.5. So step 3 is done. Go to step 4. So now you compare p with alpha, right? P is obviously greater than alpha. Then we're gonna fail, reject the null. And the last step, conclusion. Since you failed to reject null, we conclude we don't have enough evidence that the 2 operators are producing different results, right? So that kind of indicates the 2 operators are producing the same results. Okay? So that completes the pair t-test. All right, so the second animal for this attended points will be a peacock. This is a practice. I normally ask students to work through this in the class. The study wants to show if the twin brothers are taller than the twin sisters. A simple random sample of 6 pairs of twins are sampled, and the data are shown as below. They're all measured in centimeters for all the units. And then we need to perform appropriate tests to answer the question. The question is, if the twin brothers are taller than the twin sisters. Okay? So in this case, you can see the sample are selected in pairs, right? It's selected through 6 pairs of twins. Then when you have 2 groups of samples, are they dependent or independent? They're from the same family, same twin family. They have a lot of genes. That some of the genes will determine their height, right? So they should be dependent. So the 2 group of samples are selected in pairs. Right? If they're dependent, then the procedure we need to use is we need to do a paired t-test. Right? And for a paired t-test, we need to define the difference. And sometimes students are struggling about how to define the difference. You can define the difference either way you want. You can use brother subtract sister. You can also use sister subtract brother. Define difference is arbitrary. But then once you define the difference, your alternative hypothesis will be dependent on how you define the difference. So as long as you're consistent, you can define the difference either way you want. Okay, so for example, we are going to define the difference as sister subtract brother here. Okay. Then when you have the difference, you need to make sure all the difference will be defined as corresponding, sister subtract brother, right? So 161 minus 167, that's negative 6. 165 minus 174, that's negative 9. And 171 minus 188 is negative 17, right? And then 165, 173, negative 8. And then 166, 168 minus 166, positive 2. 160 minus 176, that's negative 60. Right? So if we work through this, we're going to do a paired t-test because the 2 samples are dependent. And then the difference we have is we use sister subtract brother. Okay? Now we need to write a hypothesis that's consistent with how you define the difference. Okay? So what's our hypothesis? The claim is the brother in the twin family will be taller than sister. Right? So then this should be, so the brother height will be taller than the sisters. Then you have 2 groups. You're comparing brother and the sister, right? So what does it mean from here? Brother will be taller than sister, right? Sister will be shorter than brother. And if you rewrite it, it will be sister subtract brother is less than 0. That means the difference we calculated will be less than 0, right? The difference we define here need to be less than 0. And that's going to be our alternative hypothesis. Mu of the difference is less than 0 versus the null hypothesis, mu of the difference is equal to 0. Okay, so the first step is done. Second step, state rejection rule. If P is less than alpha, then reject the null. So then we look at the problem. Does it give us an alpha anywhere? It didn't, right? Then don't worry. If we didn't get alpha, we use our default. The default is 0.05, right? And step 3, we need to calculate test statistic. The test statistic will be x bar minus mu divided by s over square root of n. And everything here is going to be about the difference that we find, right? Then we need to find each of these, x bar of the difference, s of the difference, mu of the difference, and n of the difference. Mu of the difference comes from your null hypothesis. It's 0, right? N of the difference depending on how many difference did you calculate after, right? You have 1, 2, 3, 4, 5, 6, right? You're only going to look at the difference here, right? So you have 1, 2, 3, 4, 5, 6. You have 6 sample size. So n equals 6. So now we need to calculate mean and standard deviation of the difference. We already have, the difference calculated. We just need to, calculate the mean and standard deviation of the variable difference. So if you calculate it, remember chapter 2 process. We're going to do the calculation real quick here. So we need to remember the numbers, -6, -9. So -6, -9, this will be your xi's, right? Your start with. And then -17, -8. So -17, -8. And then you have +2 and -16. +2 and -16. So from here, we can calculate a column total of the first column. So you have 6 and 9, -15, -32, -40, and -38, and -54 divided by 6. This would be -9, right? I'm sorry, this is -54. I'm sorry. I did it too fast. So the column total will be -54. Just add them all up, right? But this means the sum of xi equal to -54. And then from here, we can get x bar as sum of xi divided by n will be -54 divided by 6, which is -9, right? So x bar will be -9. Then the next column is xi minus x bar, right? So -6, -9, +3, -9, 0, -17, -9, -8, -8, -9, +1, 2, -1, +11, -16, -1, -7, right? And the last column here, xi minus x bar squared. We're not going to use this here. I need to have a squared. We need to have a column total here calculated. All right. So then 3 squared is 9, 0 squared is 0, -8 squared is +64, 1 squared is 1, 11 squared is 121, 7 squared is 49, and then we add them up, right? So if you add everything up, this will be 9 1 is 10. 121, 149, that's 170, 180, and 64, that's 244, right? So then this column is summation of xi minus x bar squared, right? Then your standard deviation will be summation of xi minus x bar squared divided by -1, that is square root of 244 divided by 6 minus 1, right? And if your calculator can calculate it, that is 6 point. Okay. So that means x bar will equal to -9, standard deviation equal to 6.9. Then we plug in the numbers in there, -9 minus 0 divided by 6.99 divided by square root of n, and is 6, right? And we calculate. So if you calculate correctly, we got negative 3.154. Then the test statistic is calculated. Now we need to find p-value. P-value will be related to your alternative hypothesis. Don't forget, always check on the signs. Smaller than sign will be probability of t. Smaller than calculated t, right? That's the definition. Calculated t is right here, so that will be probability of t smaller than negative 3.154. Now this is a t event. We need to look it up in the t table. So we need to convert a sign to be greater than sign. Then we use the symmetry rule. Probability t greater than positive 3.154. Right? And now it's consistent with the z table, with the t table. We need to go on the t table, check on the degree of freedom. -1, maybe 6 minus 1 equal to 5. So we check on the 5 degree of freedom on the t table. 3.154. That will be between 2.757 and 3.365 as the two neighbor. The corresponding probability is 0.02 and 0.01. Right? So that means our p-value is between 0.01 and 0.02. So step 3 is done. We go to step 4. So now we are able to compare p and alpha because we find out both, right? So p will be smaller than alpha. Then go back to the rule. We need to reject null. And the last step, conclusion. Since we reject null, we say we have enough evidence that, brother is taller than sisters, right? In a twin families. And this test then based on alpha of 0.05. So that's the whole process of a PRT test for this problem. So I have difference defined as sister subject brother here, but on the PowerPoint, you can see we define the difference here as brother subject sister. And the difference is your alternative hypothesis now will become mu is greater than 0 instead of mu is less than 0. And then your corresponding difference, all the signs are reversed, right? So when you calculate the mean standard deviation, your mean will become positive 5, and your standard deviation is always positive, right? 6.5. And when you work on a problem, everything, your calculated t is going to be a positive 3.154. It's the reverse sign. But when you look at a p-value, the p-value is going to be determined by the alternative hypothesis, right? You have a greater than sign here. The p-value will be t greater than calculated, right? So then you end up having the same p-value between 0.01 and 0.02, and it's still going to reject the null, and then we end up having exactly the same conclusion. We conclude that we have enough evidence that the twin brother will be taller than twin sisters. Right? So, like we said, it doesn't really matter how you define the difference. You can define the difference either way, as long as you're consistent afterwards, especially when you state your hypothesis. Right, so this is it for PRT test. It's for dealing with two group of samples that are dependent. So you need to identify if the two group samples being dependent or independent, just by the design of the state. The dependent means the two groups are going to affect each other. In most cases, it will be either the two groups are measured from the same group individuals, or the two groups are selected in pairs. Okay? So this is it. Let me know if there are any questions. And I'm gonna stop right here. Thank you.